Worksheet 16b, combine loading. For the structure loaded as shown, determine the principal stresses, sigma 1, sigma 2, and the maximum shear stress at points A and B, maximum shear stress, tau max. The first, find out the external forces, but in this case, you don't have to. You can be able to find out the external forces at the fixed part on the left. But if I cut the shaft through the section that go through A and B and consider the right portion, in that case, I call that portion is ABC, and the other point at the fixed support, I call that D. So if I call the right portion ABC, and as you can see, for 3D, we cut the multi-force member is exposed to 6 unknowns. We see Fx, Fy, Fz, and I assume the positive and the direction of X, Y, Z as shown. And you also have Mx, My, Mz, and in this direction of on of the Mx, My, Mz, I assume the positive follow the right hand rule, so that what you have. And from that we can, similar to worksheet 16a, I sum up all the force in X, Y, Z, and then moment about X-axis, moment about Y-axis, and moment about Z-axis. So we can be able to find out Fx equal to negative 325 pounds. Negative stand for the force go through that cross section on member ABC is negative, right? So with that, as you can see, so if you want, you can put it down here on that right here, so that we can have it on ABC, and this on ABC, and 0 we don't need to, on ABC, on ABC, and on ABC, because the other side ABD will change opposite direction for both forces and moments. So that's what I'm going to write down. Now the question asks what is the stresses at point A and B. So let easy to consider by cut out the left, so that it's exposed to the section through A and B. So let me portion ABD. So let cross section through ABD. So we have the circle, so it will not have no hidden on the part of AB. Then we have here, we have D, and we have that one, and this is a fixed support, and that called D. So now I expose the shaft on the left. So we have that here, that is B, and we can put down the x-axis, go out of the cut, x, and of course y-axis, and z-axis, vertical, based on my assumed direction there. So that is z. So remember B just go through G, so let dot correctly there for B, that B, and then we have a y-axis, which is y, and for point A, as you can see on the x-y plane, so point A here, if we draw there, it will be that point A, and that we have, that is, let's put down, that is B, and this is A. And with that, fixed support at D, and when you cut member through AB, we already know the internal force at section that through A and B, and we just find out. And now because when you have that on member ABC, then you just flip the sign for member ABD, right? So that what we have. So FX negative 325 on ABC, so it will be positive. It means that same magnitude, opposite direction. FX here 325 pound. Moment about X 1280 positive on ABC, so it will be negative. It means based on the right hand rule, it opposite direction, so it will be opposite direction, so that you have mx equal to negative 180. If we already put the direction, so you can show the magnitude only on this cross section, magnitude only, so we can erase this magnitude. So that is pound inch. And similarly, we have FY 160 pounds positive on ABC, then it will be negative, opposite of Y direction. So here 165, that will be go that way. So that, as you can see, that one, it will be 165 pound on ABD. Moment about Y is 2,565 pound inch on ABC, which is positive based on the right hand rule. Positive. Then it will be negative based on the body ABD, because opposite on the other side. So with that, we can have, get the red color, that MZ, and that here FY, and we have MZ, MY equal 2565 pound inch, and we have FZ 0 and MZ equal to negative on ABC, then it positive on ABD. So let's see here. So you have positive, which is that, and MZ equal to 10,245 pound inch. So that all the internal forces on cross section AB and on the member ABD. So with that, when we have the internal forces, we can go ahead to apply stress and use superposition, consider one load, one moment at a time, and that will be go to the next video.